Inside an ant colony group, every movement has meaning. What may look like random activity is actually a complex system built on cooperation, communication, and survival. Ants are among the most successful organisms on Earth, not because of individual strength, but because of how they function together as a group. An ant colony is made up of thousands, sometimes millions of individuals. Each ant belongs to a specific group, and each group has a role that supports the entire colony. There are worker ants, soldier ants, and at the heart of the colony, the queen. Worker ants form the largest group within the colony. They are responsible for finding food, building and maintaining the nest, caring for the young, and keeping the colony clean. Every day, worker ants leave the nest in search of food, guided by chemical signals left by others before them. These chemical signals, known as pheromones, are the primary language of an ant colony group. Ants do not speak or see very well, but through scent, they can share detailed information. A single pheromone trail can lead hundreds of ants directly to a food source. When food is discovered, the colony responds quickly. Ants move in organized lines, working together to transport food that can weigh many times more than a single ant. This teamwork allows the colony to collect resources efficiently and survive in competitive environments. While some ants search for food, others remain inside the nest. These ants care for the eggs, larvae, and pupae. They carefully clean, feed, and protect the developing young, ensuring the future of the colony. Another group of ants focuses on construction. They dig tunnels, expand chambers, and adjust the structure of the nest based on the colony's needs. Temperature and humidity inside the nest are carefully regulated, creating a stable environment for survival. Defense is a critical part of colony life. Soldier ants are larger and stronger, with powerful jaws designed for protection. When the colony is threatened, they are the first to respond, forming defensive lines and attacking intruders. At the center of the colony is the queen ant. She is not a ruler giving orders, but she plays the most important role in the colony's survival. Her primary function is reproduction, laying thousands of eggs over her lifetime. The presence of the queen also helps maintain order. Her chemical signals keep the colony united and prevent workers from reproducing. Without the queen, the colony gradually loses organization and stability.
What makes an ant colony group remarkable is that there is no central control system. No single ant understands the entire colony. Instead, complex behavior emerges from simple actions repeated by thousands of individuals. Each ant follows basic rules, responding to its environment and the signals around it. Together, these simple behaviors create an intelligent and adaptive system. This process is known as collective behavior. Ant colony groups are highly adaptable. When food becomes scarce, foraging patterns change. When danger increases, defensive behavior intensifies. The colony adjusts continuously to survive. Scientists study ant colonies to learn more about cooperation and efficiency. Ant behavior has inspired research in robotics, computer science, and artificial intelligence. These tiny insects offer insights into how large systems can function without centralized control. Ant colonies have existed for millions of years. They have survived climate changes, predators, and competition from other species. Their success is built on unity, communication, and division of labor. Inside an ant colony group, every ant matters. Individually, an ant is small and vulnerable. But together, they form a powerful and resilient society. This hidden world beneath our feet reminds us that survival is not always about strength. Sometimes it is about cooperation, organization, and working as one.
Within the colony, timing is everything. Ants adjust their behavior based on age, need, and environmental conditions. As worker ants grow older, their roles often change, allowing the colony to remain flexible and efficient. Not all ants leave the nest at the same time. Some specialize in short-distance tasks, while others travel far from the colony to locate new food sources. This balance reduces risk and increases the chances of survival. Ants are capable of solving complex problems as a group. They can find the shortest path to food, rebuild damaged nests, and respond to sudden threats. These solutions emerge naturally, without planning or leadership. Inside the colony, waste management is carefully organized. Certain ants are responsible for removing debris and dead individuals from the nest. This behavior helps prevent disease and keeps the colony healthy. Ant colonies also interact with their surrounding environment. They influence soil structure, nutrient distribution, and even plant growth. In many ecosystems, ants play a vital role far greater than their size suggests. Seasonal changes affect colony behavior. During colder periods or food shortages, activity slows and energy is conserved. When conditions improve, the colony quickly returns to full operation. Through millions of years of evolution, ants have perfected cooperation. Their success is not accidental, but the result of constant adaptation and efficiency.
Ant colonies are constantly monitoring their environment. Changes in temperature, humidity, or food availability immediately influence colony behavior. This sensitivity allows ants to react quickly to shifting conditions. During periods of heavy rain or flooding, some ant species relocate parts of the colony to higher ground. Workers carry eggs and larvae to safety, prioritizing the survival of the next generation. These coordinated responses happen without confusion or delay. Ants also display remarkable learning behavior. They remember successful foraging routes and avoid paths that previously led to danger. This shared memory strengthens the colony over time. The structure of an ant colony supports long-term survival. Tunnels are designed to control airflow and protect against extreme temperatures. This architecture helps maintain stable conditions deep inside the nest. Ant colonies interact with other species in complex ways. Some form mutualistic relationships, protecting insects that provide food in return. Others compete aggressively for territory and resources. Despite their small size, ants are dominant insects in many ecosystems. They influence food chains, soil health, and nutrient cycling. Their impact extends far beyond the colony itself. As the colony ages, its organization becomes even more refined. Experience improves efficiency, and tasks are completed with greater precision. The colony grows stronger through time. Through constant communication and cooperation, ants maintain balance within their society. Every action contributes to the stability of the group. This balance is essential for survival.